A large population of sheep, their weights are normally distributed with a mean of mu and a standard deviation of sigma. A random sample of 100 sheep is taken, the mean weight is x bar. So for this one, all you're going to say is the distribution is going to be mean, comma, standard deviation squared or variance over 100. That's what we do for selecting from a sample. That's the distribution you're going to use. Part B, the sample values are summarized. Sum of x equals 3782. Sum of x squared is this, where x is the weight of the sheep. Find the unbiased estimates of mu. Well, mu is just going to be the sum of x over n, and the variance, I love this part, it's the sum of x squared over n minus 1 minus the sum of x quantity squared over n times n minus 1. And that must be in your formula packets because I didn't remember the n times n minus 1. I didn't remember that. This is obvious, isn't it? 3782 over 100. Sure. If it's 3 significant digits, it's 37.8. Then for this one, when you do that number, you don't square it, you just take that number divided by 99 minus this number squared over 99 over 100. They got the variance equal to 124. There was probably some decimals on there, 0.3006, I think. You just plug these numbers in. Yeah, don't put it in any other way. It's an unbiased estimate, so we got to put those in. I don't think it'll work any other way. Then it says find a 95% confidence interval, your favorite thing in the world. That 95% confidence interval is going to be mu plus or minus that coefficient 1.98 for 95, square root of this squared over n. I'll let you do that with your calculators. And they had 35.6, comma 40.0. That's what they got. And then for the last part, test at the 1% significance level, null hypothesis H0, mu is 35. Alternative hypothesis is mu greater than 35. And when it's mu greater than 35 and mu equal to 35, what tail test is that? 1 or 2? This is a one-tailed test. So they had 2 ways of doing it. I like this one. They found the probability 0.00650 with 99 degrees of freedom. Okay. And anybody know how they got this on their calculator? That was a mystery to me. T-test. And then you put these values in. One tail, 35. Would they go to infinity? Is that what they did? Or is it? It's just one tail if you put the mu in. Okay. So then if we're looking at a 1% significance, what can you say about P and 1%? Greater than or less than? Is this less than or greater than 0.01? This guy. Less than. Therefore, what do? We reject null. And they said accept the alternative. That's one way. The other way they did it, which I thought was okay, still one tail. And then what you do there is you're going to, they got 37.82, 99 degrees of freedom. And we're going to reject if t was greater than 2.36. And the t-test gave us 2.5294, which is less than 2.36. Therefore, reject null, accept alternative. This did not make any sense to me. This one made the most sense to me.